Hello everyone, welcome to next round coding. Today we're going to solve LeetCode 4016 maximum area of two non-overlapping square submatrices. So let's understand the problem. The problem states that we're given a matrix which is filled with zeros and one. We need to find two submatrices which are filled with one and which are square and both are non-overlapping. Now we need to return the maximum area of the submatrix, right? So if we see that we have this square submatrix which is filled with one and it is square, right? And we also have a submatrix which is like this. This is also square and filled with one, but they are overlapping. They are sharing a common cell, right? So these two submatrix not validate our condition. So these two submatrix we will not take. So just remove it. But if we choose this one, then these two submatrix is square, is filled with one, and both are non-overlapping. They are not sharing a common cell. So this submatrix size can validate our answer. So this size is 2 plus 2 will be our area, which is 4. We need to return 4. For this case, this 4 will be our maximum area because there are no other submatrix which have greater area than 4. So I hope the question is clear to you. Now let's understand the solution. So as you can see, if we have a bigger size submatrix which are filled with 1, we can also say the smaller size submatrix will be also filled with 1, right? Suppose we have a submatrix which is filled with 1, right? Now if this submatrix is filled with 1, then the smaller size of this submatrix will also be filled with 1, right? So if we have a submatrix of size k which is filled with 1, the smaller size of k also filled with 1, right? And if this size k submatrix validates our condition, means we have two submatrix of this k size and both are filled with 1 and both are non-overlapping, then the smaller size of k submatrix will be also validate the same condition. We don't need to check it, right? So if we have something like this, means if the k is 1, 2, 3, 4, 5, 6, dot, 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 and we find that for k equal to 4, our condition is true. Okay, means this validates our condition. Then all the smaller size which is less than k will also automatically validates our condition. This will also true, this will also true, this will also true, right? And we just need to check the bigger size which is greater than k validate our condition or not, right? It can be false, it can be true, we don't know, we need to check it, but it is sure that the smaller size will be true, right? And this way we will find that there will be a sequence of true and suddenly there will be a false, and the next size will also be false, right? Because once it becomes false, the next greater size will be automatically become false. If we see this kind of pattern, what idea we generally suggest? So we suggest nothing but binary search. So we can do binary search on this size k and check for each size k if we have two submatrix which is filled with 1 and both are non-overlapping. then we can just do the binary search and try to find the optimal answer. Now the question comes up, how we find that this submatrix of k size is filled with 1 or not, right? We need to find that the submatrix is filled with 1 or not in lesser time, right? We can do a 2D prefix sum. We can do the 2D prefix sum of this matrix and check the prefix sum of any submatrix is equal to the area of the submatrix or not. Suppose the prefix sum of this submatrix is sum and area will be k into k. If the sum and k into k is equal, then all these values are filled with 1, right? Because there is only two values, 0s and 1. So if it is lesser than k into k, that there is obviously some zeros over here. If the sum is equal to k into k, then it is all filled with 1, right? So we need to implement the prefix sum as well, right? The 2D prefix sum, because we are implementing in a matrix. Now, once this two job is done, the next job is how we find that these two submatrices are non-overlapping, right? We need to find it, because if we have a matrix, this matrix is all filled with 1. Suppose this matrix is all filled with 1, and this matrix is also filled with 1, but they are not overlapping, right? There is overlapping. So these two are not validate our condition. So we need to find that is this overlapping or non-overlapping. How we can check it? So we can check it something like this. Now, for a submatrix, we have a top point, we have a top left point, top right point, bottom left point, bottom right point, right? If we have 4 variables, which is max row, min row, max column, and min column. If we have these 4 variables, we can find what is the max row of any submatrix which is filled with 1. Suppose this is our max. This is our min row. Suppose this submatrix also validate our condition. So this will be our min row, right? And this will be our max row and this will be our min row, right? Similarly, we can find the max column and min column as well. So for this case, the min column will be the 0th one and max column will be something over here, right? If we have this max row, max column, min column, so we can just have the overview that our submatrix will be lying in these 4 positions, right? So if our max row, or just we say our min row plus the size we are trying is k, is lesser than or equal to our max row, or our min column plus k is lesser than or equal to our max column, we can say there will be obviously fit 2 matrices over here, right? Because our min row plus k is lesser than max row and min column plus k is lesser than max column. It is obvious that we can fit 2 submatrices over here, right? Is it clear? We just need to check if this is validated or this is. We don't need to check with the both. If one is true, then our answer is true, right? So in this way, the overlapping condition we can also check. So we have done with it. So we need to do the binary search on k. We need to do the prefix sum to validate the submatrix is filled with 1 or not. Also, we need to track these 4 variables to check these two submatrix overlapping or not, right? So this way we can do it. Now let's see the code. Okay, now let's do the code. So we have in, which is the mat.size, and tm let be mat of 0.size. We need to create a 2D vector for prefix sum n plus 1 comma vector of 90 n plus 1 comma 0. Now let's do the prefix sum over here. Less than 0 n I plus plus or I j equal to 0 j less than n j plus prefix of I plus 1. There will be second of bracket. So second prefix of I plus 1 comma j plus 1 would be format of I plus I comma j plus prefix of I j plus 1 plus prefix of I plus 1 j and minus prefix of ij, right? The prefix sum is done over here. Now we need to do the binary search. And the low will be, obviously there will be, if we see that, okay, low will be, minimum low can be 1 and our high will be minimum of n comma m, right? Now we need to do the binary search over here. So just do n less than equal to h, find the mid, it will be n plus r by 2 if our calls of mid comma or prefix sum is possible over here, then our answer will be our mid and L would be our mid plus 1 because we need to check the right half, and else we just do h equal to mid minus 1. At the end, we just need to turn answer into answer, right? We also need to declare our answer as 0, right? So this is done. Now just do this pause function, going to be a boolean function. Pause. We take our k and our vector of id prefix, right? So there is the sum in, which is the prefix dot size minus 1 and m prefix of 0 dot size minus 1 because we have taken the prefix array n plus 1 and m plus 1, so that's why minus 1. Now we need to do the 4 variables. So do 90 max row as our n and is max call, it will be in, this will be our min row. Min row would be initialized with n and min call will be initialized with n and max will be initialized with minus 1, right? This is done. Now let's iterate it over this prefix array. So for 90 r equal to 0 r plus k, so then equal to n r plus plus for 90 t equal to 0 C plus K and then equal to name C plus plus. Now check the sum. Sum would be prefix of R plus 1 C plus 1 minus prefix of R comma C plus 1 minus prefix of R plus 1 C plus prefix of R and C. Right? We get the sum. Now, if our sum is equal to K into K, right? If this is true, then we just update our score variable, right? So our max row would be max of max row comma R min row will be minimum of min row and R min column will be minimum min column comma C and max column will be max of max column comma C, right? This is done. Once this is done, if our max of is still -1, just we return false because we have not got any submatrix of which will it 1, right? So we return false, right? Now, if our min row plus k is lesser than equal to max row, or min col plus k is lesser than equal to max column, then we return true, right? And at the end return false, right? This is done, and the whole code is done here over here. Now let's run it and check it. Oh my bad, this will be our L and H, right? Now let's run it. Okay, there is some wrong answer. Let's check the code once. So this is done over here. So there will be a M, and we need to check for k size submatrix, right? It will not +1, it will be plus k, this will be plus k, and this is also plus k, plus k. Now this looks good. Run it. Yeah, as you can see, it is running fine. Submit it. Yeah, it is accepted. Now let's talk about time and space complexity. The time complexity over here is big O of n into m and log of minimum of n comma m. Log of n into m because we are iterating over this matrix, and log of n into m because minimum of n and m because the k would be the minimum of n and m because I is minimum of n and m. That's why the time complexity would be n into m log of min of n comma m, and the space complexity would be simply big O of n into m because we are using the prefix array which is size of n plus m. That's why space complexity is n into m. So I hope the solution is clear to you. If you have any doubt, you can comment me out. And if you are benefited with this video, please do like, share and subscribe. Thanks for watching.